Okay, so just with the last chapter, chapter 3, about the role of government, non-government organisations, you probably realised at the exam revision session that they spent all of 30 seconds talking about this particular topic area, because it just hasn't been a topic area that's been targeted. And when it has been targeted, they've been really generous with the marks, in that you just need to explain how something tries to improve physical activity levels. So what I thought we would focus on, I guess, is just these key roles. And I think it's just going to be a case of just remembering those, like learning those key roles. That's the only thing that I can see them specifically asking questions about each of those 4 and the difference between each of those 4. Because it does mention them in the study design, I don't want to say to you, don't worry about them at all. But I think if you just make sure that you know those, remember those, then that will be fine for that there. Now, if you look at the questions, as I said to I think a few of you, I went through so many exams, all sorts of exams to try and find questions on this, but there just weren't questions on that. So these are the only 2 sort of VCAR ones that I found, and they were really generous in terms of what they gave. So if you see Heart Foundation, I think it's good to know an initiative, at least one initiative for each of the types of settings. So for a school-based setting, a community-based setting, and a workplace setting. But most of the time they've asked about school-based settings because they're more specific. So Heart Foundation, a natural one that you would think about would be Jump Rope for Heart. Yep. It's on Edmodo. Yeah, they're on Edmodo. I gave them out in last Friday's lesson.
Oh.
So if you were there, I think you were there. Everyone got one then, but it's on Edmodo if you don't have it as well. So all it asks there is for you to explain, identify and explain. So for 2 marks, it would be identify Jump Rope for Heart, and then just explain what it is. And if you go back to the role of the National Heart Foundation, it's linking in with heart, stroke and blood vessel disease. And if you see that, it talks about cardiovascular disease then. So that role is linked in with what it tries to do. So that's an easy one to remember for Jump Rope for Heart. And then with the next one, name and outline a population-based government or non-government initiative or strategy that could be implemented in schools. That sounds like quite a complex kind of question. But then if you look at the answers that are over here, again, Jump Rope for Heart, like you could have gone Jump Rope for Heart again. Something like mandated PE lessons was actually one that you could have put in there, because I guess that's a government initiative that they put in, they mandate PE lessons. So that would be a good one that you could have in there as well. And look, it said types of responses that they accepted. They accepted ride to school, modified sports, like they're really generous with these sorts of questions. And 67% of the state got 2 marks on it, because what you really needed to do was just to be able to explain how mandated PE will improve physical education. So it's sort of common sense that they've asked thus far. Now, this one here wasn't a VCAR one, and it was a little bit more specific. And this idea of walking to school with as many supervisors as there are children there, but what is that?
Walking to school bus.
Yeah, walking to school bus, exactly right. So well, this isn't a VCAR question, and everyone who's got links in with VCAR says that you won't need to know a specific one. I think walking to school bus is a good one to be able to know what it looks like. And I think Jump Rope for Heart is the only 2 that I've seen that they've really specifically spoken about with those 2. So I think it's good to know those 2. And describe how it works and what it hopes to achieve. So any sort of physical activity promotion aims to increase physical activity levels by targeting lots of different levels of the social ecological model. So I think that's walking to school bus does so really, really well, because it allows, well, talk to me about how does it address the social level?
With other friends.
Walking with their friends, exactly. Individual level?
It's safe.
Yeah, perceived safety. Yeah, exactly right. Walking, easiest possible skill. Good. What about policy? Exactly. Yep. Certain number of people, vests, exactly right. And that links in with perceived safety. And what about physical environment? Paths, exactly. That it utilises paths that are in the environment. So that's how it targets all levels. So I think it's good. It's a good idea to be able to know about that one and jump rope for heart. They'd be the two that I would have a look at. So walking to school bus, and then you need to explain it. List 3 other school-based physical activity initiatives. One which must focus on the physical. I don't really understand what they've done here. One which must focus on the physical environment, healthy spaces and places that could be implemented at your school. I don't know if that just means something like bike education is focusing on the physical environment. I don't know if that's what that means. But again, a couple, and they will never ask you 3. I would just go with, if you've got something like that, I would go with jump rope for heart, walking to school bus if that's an option, and mandated PE lessons. That would be the 3 that I would go for. And then this one just leads on, identify 1 hurdle obstacle restriction for 2 of the initiatives that you've encountered. So that's easy with bike education or bike ed. Access to bikes might be an issue. Skill level might be an issue. So if you just think about those and link those in with accessibility to equipment or accessibility in some particular form, then that should be fine as well. So really general questions that they asked. They haven't asked that many. As I said, I scoured all the exams, and this was the only thing that I could find. And I haven't looked through the 2015 exams to see if there are any, but I certainly wouldn't spend a heap of time learning about 6 or 7 interventions for each of the settings, and school-based seems to be what they're targeting a little bit there. Any questions about that? So just as a final review, I think you should know the roles for each of them. I think you should know about an intervention for each of the settings and make sure that you can explain that intervention, and a lot of it's common sense as well. All right, so let's look at acute responses now. So acute responses really linked in with chronic adaptations, and that we use the same sorts of terms. So what you need to know, I've put up here, what you need to be able to do. So you need to be able to identify the responses that occur in the body when we start to exercise. You need to be able to classify responses. What do you think that means? What would we classify them as? Exactly, as to the body systems. Whether it be cardiovascular, respiratory, or muscular. Remembering that there's a little bit of crossover, and sometimes they accept, like AVO2 difference, they accept as muscular or cardiovascular, but you need to be able to classify them. You need to be able to explain for the acute response if it's an increase. So what is an example of one that's an increase? Stroke volume, respiratory rate, exactly right. Or if it's a decrease, what will be a decrease? After exercise as an acute response, or that's a chronic adaptation, heart rate.
Blood flow to not working.
Yeah, good. Yep, blood flow to organs might be a decrease. Yep, what's another one? There's one that I've really got in my mind.
Decreased fuel.
Yep, substrate stores, exactly right. Yeah, a decrease in substrate stores, absolutely. Explain how it assists performance if that's relevant. So if you're looking at muscle substrate stores decreasing, that's not going to improve performance. But if you're looking at an increase in heart rate, increase in stroke volume, that's going to improve performance. So if it's relevant, explain how it assists performance. Apply what you know to a graph, or apply what you know to data, and we're going to look at a data example very shortly. Explain what happens for those responses if it's different, rest to submax and submax to max. So what's the main one you think of, or what are a couple that you think of when we say that might be different in their response?
Tidal volume.
Yeah, and
increase in episodes.
Yeah, good. And what's the other one? Stroke volume, same thing. Yeah, exactly right. Good. So where there's a greater increase from rest to submax as opposed to submax to max. There's not too many that have a great difference there, but it's good to know those that do. And also talk about the difference in response between a trained athlete and an untrained athlete as well. So let's have a look at that. Firstly, let's have a chat about at the simple level where you're identifying whether the change increases or decreases and then explaining how it changes. Tidal volume, as soon as you start exercising, so that's what this is asking. It's not asking you at this point to differentiate between rest and submax and max. So change in tidal volume when you start exercising, what happens? Increase or decrease? Or stay the same? Increase, good. None of you girls are doing the arrows up and down, but can I just reiterate what Rob said? I don't know if Rob said or Mark said. That Some years they're a bit more generous with arrows up and down, but all it takes is that cheapest SR ratio to stay. Now this year I'm not accepting it, and I think I marked 2 papers last year out of 200 that the person used arrows, and they got the marks last year, but I'm really worried that she's just going to say we need to be able to differentiate between people who are being lazy and people who are, taking care. So I'm really worried about that she's going to do that there. So just don't do increase or decrease as arrows if you don't know I'm doing them. Yeah. Minute ventilation, what happens? Increase, decrease, stay the same. Increase, what is minute ventilation? Amount of air per minute. Lung diffusion. Increase, what else might we know that as? What else might we call that? Yeah, gas diffusion, gas exchange, or pulmonary diffusion. Yeah, so different words, same thing. Muscle substrate stores? Decrease. Good. So our justification. So why does tidal volume increase during exercise, when we start to exercise? We've had to cast our minds back to the way we used to write those. So let me put some words in there for you and you guys can sort of create the sentence around it. So the justification is that we need to have an increase in air so that we get an increase in oxygen, yeah? And we need to get an increase in oxygen to meet the demands of the exercise because our oxygen requirement is higher. Yeah, agree with that? Yep.
So minute ventilation is the amount of air you breathe, not the amount of oxygen.
Correct. And tidal volume is the amount of air per breath as well. So we need to link it in with our justification to what the body's demanding and then what our response or how our response is meeting those demands. So you might say, what did I say? Deeper breaths equals more air equals greater oxygen intake, which ensures oxygen demands are being met. So that's just what I wrote down, sketched down as a little one there. But I think it's important to talk about in here. You want to make sure that you talk about oxygen increasing and meeting demand. It's a very similar response for minute ventilation, isn't it? Because it's a greater amount of air, greater amount of oxygen, therefore it's going to better meet the demands of the physical activity that's being undertaken. Now when we're talking about lung diffusion, what are we talking about? Carbohydrates? That's all right. Yeah, exactly right. So when we're talking about lung diffusion, we're talking about both of them. We're talking about a greater diffusion of oxygen into the blood or into the body and a greater release of carbon dioxide out of the blood because that's being produced as a result of exercise. Yeah, exactly right. So I said more oxygen is extracted due to the demands required for exercise, and more carbon dioxide is released due to the increase in production of carbon dioxide during exercise. Removed, released, either one.
And you can't say O2 or CO2.
Yeah, you can.
Okay.
Yeah, they're scientifically
That's
recognised.
O2.
Yeah, absolutely you are. Yeah.
So you don't have to put it.
Not for oxygen and carbon dioxide, nor for carbohydrates, CHO for carbohydrates you can do, hydrogen, H is fine, calcium, Ca, they'll accept either, it's okay. You be specific, you write H+. No, write H+, but they'll accept. Alright, muscle substrate stores, why do they decrease? You're using them, yeah, at a faster rate. Why is that? Yeah, to produce energy, to be more specific, to resynthesize ATP. Exactly right. And when we're talking about muscle substrate stores, I would also like for you to mention what they are or some examples. So what would you say? What could you say for your muscle substrate stores? What are some examples? Yeah, carbohydrate, or let's say glycogen. Yeah, what else? Did you say something, Eliza?
No.
No? CP, yeah, exactly right. They're probably the two that I would mention as soon as you start exercising. I mean, you could say triglyceride as well, you could say ATP, but I think I would go with those two as my examples because they're the ones that you notice the most. Good, really good. So it would be a good idea to have a table of all those responses, and I know you probably have that in your chapter summary. At the base level, that's what you'll need to be able to do. Let's start going a little bit more challenging now. So I said that one of the things that you need to do would be you need to explain the difference between a trained and untrained athlete in terms of response. So this question here, I've just made this one up. Explain responses to lactate concentration in the blood. Actually, it was on the SAC that I gave the guys last year. in the blood during the initial stages of the beat test when comparing a highly trained marathon runner as opposed to an individual who has just begun regular cardiovascular training. So you could say a beginner or a novice. So elite versus novice, trained versus untrained. So in this question, you would be looking at saying what the response is from the marathon runner versus the response from the novice or the non-trained, and justifying why you said that.
How do you know it's not asking for chronic adaptation?
Because it says explain responses during the initial stage of the beat test. So that's an acute response because you're starting to exercise. And then it is asking essentially about chronic adaptation. It's asking about the difference between the two of them. But the question is saying during the initial stages of the beat test, which says that they just started exercising, so therefore you need to put in a Q response.
What does it mean in response to the blood lactate concentrations? I don't understand how that, I get it.
You don't understand what the question's asking?
Yeah, well,
so in terms of...
why is it in relation to lactate concentrations in the blood?
Think of it as lactate production. That's fine as well. Lactate. So explain, or is it the word responses that you think is tripping up?
Responding to the lactate concentrations. Like, do you get what I mean?
Yeah, I understand what you're saying. Explain, let's when you get a word that you don't know where it belongs there, just take it out. So like explain lactate concentrations in the blood. Does that make more sense? Yeah. During these initial stages. It's probably not the best word to put in there to ask. Yeah. It's explaining like the response of the blood lactate to exercise.
Yeah.
It's probably not worded as well as it could have been. All right, have a go. Yeah, so often they put words in that are a little bit tricky, and I find 90% of the time, if you take the word out and read it without it, it makes perfect sense. That's asking the same thing. Like they keep throwing in, you guys know this because I put in, but they kept throwing in a few years ago like parameters, and people didn't know what that meant. It was like explain cardiovascular parameters that increase. And if you just took it out, like explain cardiovascular increases, like it made sense without it.
So, okay, sorry, I'm still a little bit confused. So are you comparing the different acute responses between a marathon runner and a
Correct.
normal person?
Correct.
But it's submax.
And how would they be?
So think about, let's talk it out a little bit then. So who would you expect to be a more efficient athlete? Marathon runner or the novice? Marathon runner. So would you expect the aerobic system to take over earlier and the dominant system in the marathon runner or the novice? Marathon runner. So if the aerobic system is more efficient and takes over sooner, they're going to have less reliance on those anaerobic systems initially because their aerobic system produces energy at a faster rate. So how is that going to be reflected in terms of blood lactate? Yeah, less.
But
Exactly right.
do you actually have to say stuff like increased stroke volume and all of that?
No, it's just about blood lactate. So all you need to say is you need to say, all you need to say for this one here is you'd need to say that the highly trained marathon runner would have lower levels of blood lactate when compared with a non-trained athlete. This is because efficiency of the aerobic system takes over earlier, less reliance on anaerobic glycolysis system, and thus less lactate. Something like that would be perfect. Now, I haven't seen a question like that before, but I reckon it's a pretty awesome question that they could ask.
Because it's at submax, there wouldn't be an anaerobic.
It's always going to be a little bit just at the start. It's not going to be huge. Like the aerobic system will take over as dominant very soon. But as soon as you start going above what your resting level is, you need an increase in contribution from all energy systems. So yeah, my answer was initial concentrations in the elite athlete would be lower than that of the beginner. This is due to the efficiency of the aerobic system producing energy at a faster rate. Therefore, the aerobic system can take over earlier as the dominant system, as well as a decreased reliance on the anaerobic glycolysis system. The beginner will take longer for the aerobic system to dominate, have an increased contribution from anaerobic glycolysis, and therefore higher blood lactate. Does that make sense, everyone? Yep. Okay. We are going over you two as well. We're going to go through the rest of the Ergogena Gaze. People that haven't, both of you have already presented, haven't you? Watching the rest of that video and doing our quiz. So I will email you the quiz or put it up on Edmodo.
Okay, thank you.
This one you've seen many times before, so let's only spend a little while on it. So this is talking about the difference from rest submax and submax to max. This is where this question comes in. So we're looking at the changes in stroke volume, 45-year-old male as a result of training. So we're looking at pre-training, at rest, stroke volume was 72 mils versus post-training, rest was 80. So this is a little linked in. The question combined chronic adaptations and acute responses here. Cardiac output at pre-training at rest and post-training was exactly the same. So the stroke volume increased as a chronic adaptation and the cardiac output was the same. And then during maximal exercise, cardiac output was greater in the maximal exercise in the post-training versus pre-training, which was what you'd expect due to the stroke volume. So that's the chronic adaptation part. Now the question is, describe the changes that occur in heart rate, stroke volume and cardiac output as exercise intensity changes from submax to max. So in actual fact, I've put the information there, but do you actually need that information in there to answer that question? You don't. The first one was about chronic adaptations there. A lot of people got confused in this part and put it in there, but all we need to know in terms of our changes that occur heart rate, stroke volume, cardiac output from submax to max. So I think, if I remember, do you guys remember doing this question? A lot of people wrote about it from rest when you were doing it. I'm not sure if you do, but submax to max. So we're not even talking about rest to submax now, submax to max. So what happens in terms of heart rate from submax to max? Increase, decrease, stay the same. Increase. Stroke volume, increase, decrease, stay the same. Stay the same. Cardiac output, increase, decrease, stay the same. Increase. Yeah, pretty easy.
So that's all you have to say.
Yeah, that's all you have to say. Yep, so the increase in cardiac output is a result of I would conclude it by saying the increase in cardiac output is a result of the increase in heart rate rather than stroke volume.
Is HR an accepted abbreviation?
I don't know. I think I would write heart rate out and put HR, same thing as stroke volume. The reason why I say that is because in a couple of questions in the past, they have asked for how you work out cardiac output. Do not use abbreviations. They've said do not use abbreviations. Because cardiac output, what's the recognised sign for that? Yeah, Q, exactly right. And stroke volume, obviously SV and heart rate. But I would, just knowing what they've done the last couple of years, I would write them out and then bracket them. All right, so this is another made-up question from me. This is a decrement in muscle glycogen levels. What does the word decrement mean? Decrease. Excellent. All right, let's see if my questions make sense that I've made. So looking at that graph without looking at anything else, what do you see?
The 2 has had a more decrease.
Right, exactly right. So I've tried to flip it and make it a little bit challenging in terms of your thinking there. So the 2, whatever the 2 might be, has a greater decrease in muscle glycogen levels. So the graph above shows substrate responses following an all-out 2-minute effort. 1 or 2, one of the other, fast twitch, 1 represents slow twitch. So in terms of what is represented by 1 and 2, how do we use the information in the stimulus of the question to work that out? What's important about it?
Fast twitch decrease. Oh, right.
Yeah, dose and rate.
2 minutes.
Exactly right. So the nature of our exercise will determine the muscle fibers that are being recruited. So if we are doing a 2-minute slow effort, it would be a very different story because there are different muscle fibers that are recruited. So when we want to go in a 2-minute all-out effort, which muscle fibers would you expect to be stimulated and used during this? Fast twitch or slow twitch? Fast twitch. So are you going to see a greater response in fast twitch or slow twitch? Fast twitch, exactly right. And that's your answer. So 1 would be slow twitch, fast twitch. Slow twitch. 2 would be fast twitch. Yeah, good. I know that's quite a high percentage to see decrease for glycogen, but I wanted to make it like really separate them out there.
Can you just explain that one more time?
Yep, sure. So whatever type of effort that you're doing, your brain's really clever and it recruits the type of muscle that's going to suit that environment or that demands. So if you're doing something that's explosive, you're going to recruit the muscles with the most amount of PC in it because they're the muscles that are going to meet the demands of the exercise. If you're doing something slowly, they're going to recruit the muscles that have the most amount of oxygen supply to it because it's a slow contraction. You can take your time with your resynthesis of ATP. So if you're looking at something that's an all-out, that means maximum, 2-minute effort, that's short. Your muscles, your brain is going to preferentially recruit the muscles that are going to suit that environment the best, which are fast twitch because they produce energy faster and they're going to be able to put you at a maximal effort for longer.
Yeah.
So therefore, the changes that you will see to PC, glycogen levels, whatever, are going to be greater in the muscle fibers that are being utilised more. Fast twitch.
But isn't it muscle glycogen?
Yep.
Not PC stores.
No, glycogen.
So therefore, you'll be using more of number 2 would be using more of the slow twitch.
Fast twitch. Because glycogen's used for anaerobic glycolysis, which is anaerobic, which is produce energy fast. As well.
Wait, so it's like, I thought you just used all your PC stores.
Yeah, but 2 minutes.
Okay.
2 minutes is way too long to just rely on PC.
So in your for some reason I thought all fast twitch just had PC, so they actually have.
There you go. No, they definitely have glycogen in it because glycogen is used for aerobic metabolism and it's used for anaerobic glycolysis. And anaerobic glycolysis is more fast twitch.
So how
slow
do they
twitch.
work differently because both have glycogen, but how do they? Because wouldn't the slow twitch, because it's got more capillaries that can work with the glycogen faster?
Yeah, and slow twitch will have a lot more mitochondria, so there's a place for that glycogen to go to.
Make glycogen work better.
Yeah, definitely over a long period of time, but not fast. Because
What happens in the
fast twitch fibers might have more glycolytic enzymes to break it down initially at that starting point there. So therefore that's broken down faster at the start, but then it's got less mitochondria, so it can't go anywhere, so it just goes into lactic acid.
So athlete 1 has.
It's not athlete 1, it's just, this is the same athlete. It's just what's happening with their slow twitch fibers and what's happening with their fast twitch fibers. Two different athletes? Nah, same athlete. Fast twitch and slow twitch fibers. Makes more sense now? Makes more sense now? Okay. I get so creative and tricky with my questions, don't I? So we very much justified that now. So identify 3 other changes that would occur in the type of muscle fibers you identified in number 2. So a bit of a consequential mark. If you didn't get 2, then you wouldn't have got this here. So number 2 is what sort of fibers? Fast twitch. So what would you expect to see? Decrease in CP stores. Absolutely. Good. What else? I sort of gave one away just before.
Can you say that even though?
Yeah, because it's glycogen. Yeah. If it just said substrate, then nah, but it's just glycogen. What else? Yeah, perfect. Increase enzyme activity.
Can you say increase recruitment?
Perfect. That would be the last one that I would say as well. Yeah. Increase in recruitment of those muscle fibers as well. So that's certainly a change that you would see. Anything else that you can think of that you would see?
Increase glycogen stores.
Except that's what the graph says. But it's a great one.
What were the other ones we had? Sorry, decrease CP stores.
Decrease PCL-CP stores, increase in enzyme activity, increase in recruitment in terms of muscle fibers.
Motor unit.
Motor unit recruitment, yeah. I mean, they were the 3 that came to my mind fastest. I didn't have any more, but that doesn't mean there aren't any more. Yeah, perfect. Increased temperature. Yep.
Increased lactate.
Yep. Definitely lactate production. I would probably go lactate production over temperature. The only reason why is that temperature is the result of aerobic metabolism. So I would probably go with the lactate. I mean, it does increase in temperature, but I'll probably go with that one.
What was the temperature?
Well, there's an increase in temperature, but temperature, because heat is a byproduct of aerobic metabolism, and we're more talking about fast switchers had less aerobic metabolism in them. They do some, but not as much. Cool, that's good. All right, so hopefully you'll find lots of challenging questions in your practice exams about this, but this is a really good dot point list to go through to make sure. Any questions about what we've done at all?
What exams did you want us to do in that?
I've got a holiday homework sheet that I'll give you that has a list of them. Cool, all right.